Okay, so I've got a bit of a rat's nest here again, but what I've done is connected up the register that I've made to a bunch of other things. So over here, just out of shot, I've got my 8-bit keyboard for inputting an 8-bit number, and that can be used to get an 8-bit number into the system. Then I've got my board that I made that I showed in a previous video. This is sort of like my prototype of registers, and what it's got on here, I'm going to call this the accumulator. So this is the A register, the accumulator for the 6502. This is the X register for the 6502, and let's ignore that one for now and ignore that one and the other bits and pieces that are on there, but it's basically some registers connected together by a bus, by an 8-bit bus. Then I've got over here a switch panel. So these are a load of micro switches that are connected up so that I can toggle things and switch things inside the CPU. And over here I'm going to use the register that I made that can count up and down as the Y register, because in 6502 the Y register is an index register. The X is as well actually, but the Y is an index register that's capable of counting up and down. And then over here I've got a display which shows numbers. It's basically, I'm going to use it to convert the binary numbers that are displayed on these LEDs into decimal, because it's a lot easier to understand decimal. Now, how all these switches work is that if you press this switch here, then it publishes the number that's currently coming from the keyboard here. So I've got a number selected on the keyboard, and if I press this switch down here, I get 240 over on the display over here. Okay, so the number that's on here, the 4 bits, so it's top 4 bits on, bottom 4 bits off, when I publish that is 240. So what I'm doing there is this keyboard is effectively counting as one of the registers because I don't have any memory or a program counter as such yet. So I've got to have a way of getting literal values, numbers, into the system. So what I'm doing is I'm providing those numbers through this rubbishy little keyboard here, which is connected to the bus as well. So that counts as one of the things on the bus, which can publish onto the bus, and there's its value, 240. So let's set 129 on there. Then if we publish it, we get 129 on the bus. So we can use this at any time to see what's on the bus. You can publish something on the bus and see it on the screen, and you can get a value in from this keyboard here. So cryptically, I've written PK by this switch here to say that this switch publishes the keyboard. When you press it, press that, we publish the keyboard onto the bus and we can view its value. Okay, just to make this a little bit more intelligible then, I've got a value of 129 currently on my keyboard. I've got a value of 3 in my accumulator. So PA, the cryptic letters PA stand for publish accumulator. So we press that, and the accumulator, which is holding value 3, is published and shown on the output display over here. So we get a 3 shown on the screen. So that's publishing the accumulator. So what's happening is each of the registers can be published at any given time by sending a low going pulse. So we need to send a pulse that's normally high, it goes low and then goes back up to high again, and that pulse sent to any particular register will publish it onto the data bus. So that's publishing the accumulator, that's publishing the keyboard. And it's just the convention that I've chosen that a low going pulse is how I'm going to publish things onto the data bus. And I've made all the registers that want to take part on my data bus work in exactly the same way. They have to take a low going pulse to publish. Okay, so what does switch 3 do? Well, switch 3 publishes a 15 because switch 3 is actually publish X. So X has got the value of 15 in it in binary there. 3 publishes X, so I can publish keyboard, I can publish the accumulator, I can publish X. 4 publishes the value that's stored in this register here, but I think we'll ignore that one for now. So that's actually the result. So that's actually published result. It's the result of my really useless ALU that I implemented, but let's forget that for now. It's pretty uninteresting. But what is interesting is this Y register over here. So the Y register's currently got nothing in it, and I've wired it up so that the increase and decrease lines are on these last two switches here. That one's decrease, and that one's increase. So you can see it's counting up in binary as I press that one. So that one is, so switch 12 is, well, let's call it Y++. So that's increasing Y, and switch 11 is Y minus, because we're decreasing Y. So let's try that out. Counting down from Y, we'll count it down to 0. Well, in fact, let's count it down to 254. So obviously when it goes down to 0, it wraps around to 255 and then down to 254. So I think that one is publish Y. So I've rigged that one up. So that's PY. So I can publish the Y onto the bus. I can publish the result onto the bus, X onto the bus, accumulator onto the bus, and the keyboard onto the bus. Now, switch 6, I've not wired up to anything at all yet. Switch 7, this is where we move into the, what I've been calling store, to store things in the registers, but I suppose really load is the correct term for it, because we're talking 6502 language, so we're going to load something into a register. So what did we do then? We've got 129 on the keyboard. We want to load it into A. So what we want to do is load A with 129, which is that's load immediate in 6502 language. So load A with 129. If you're writing assembly language, you would put LDA #129 as your assembly language instruction. So in order to load something into a register, it has to take a high going pulse, and the high going pulse has to happen while the publish low going pulse is in progress. So we have to have a normally low, we do a high going pulse, and then we go low again. So we have to press the publish. So if we want to publish the keyboard and get it into A, we hold down publish A. So that's taking its low going pulse. Sorry, publish K. We hold down publish K, and we do a store on or a load into the accumulator. So that switch there is, we're going to call that load A. That loads into the accumulator. So I've now managed to copy the value from the keyboard into A. So if we put another value on the keyboard, let's put on, let's put 170 because it's a nice easy number, on off, on off, on off, on off. We could publish the keyboard and store it in our X register. So I'm hoping this one's storing X or load into X. Yep, it is. So that one there is load X. It's quite a complicated rat's nest of wires to get this all going, but I think it's working quite nicely. So I've got load into X, I've got load into accumulator, load into X. This one actually operates the ALU, so I've got the world's worst ALU, which only does the NAND function. So NAND is an AND followed by a NOT, so we will NAND A and X and get it into there by pressing this one. So that is, I'm just going to call that ALU. For now, that actually does the ALU calculation, but it's so boring I'm not going to talk about it. Then this one is my load into Y. So let's, instead of taking the value from the keyboard, let's put the keyboard down to 0 so we can check that we're not cheating. Publish the keyboard. Yep, 0 on the keyboard. Let's take the value of A, so we can publish A by pressing this thing here. And while we're publishing A, we will load it into Y. Okay, so we took the value of A and we loaded it into Y. So this switch here is load Y. And if you know your 6502 instructions, you'll know that what I just did was actually they call it a transfer AY, a TAY instruction, TAY. It transfers something from the A register into the Y register. And in actual fact, even with this simple setup, I can perform some of the opcodes. I think there's about 150 opcodes or whatever on the 6502. I can perform probably about half a dozen of them. Let's have a go and see which ones I can do. So we've transferred A to Y. I could transfer A to X. Let's do that then. So we want to publish A and load it into X. So let's publish A, load it into X. So now I've done a TAX, transfer A to X. Let's clear A out then. So if we publish the keyboard, in fact, I think if you load into the accumulator with 0 on the bus, it will clear it out. So I could actually clear out the accumulator that way. And if I wanted to do a TXA instruction, or for that matter a TYA instruction, transfer X to A, if I publish X and load it into A, I've loaded the value of X into A. So I've in fact transferred it, I suppose you could say. So I can do TXA, I can do TYA. So how would we do that then? Oh, it's already got that value in it, so it's going to be a bit boring. Let's clear load A. So this is load A with 0, and this is actually load X with 0. So transfer Y to A. So we want to publish Y, load it into A. There we go. So we're doing a TYA. Now we can do an INY, which is an increase Y instruction, which is just there. Doing. We can do a decrease Y instruction, which I think is written DEY, isn't it? Yeah, DEY to decrease Y. So that's there. So we could take the value of A, publish it into Y, transfer it into Y, increase it and transfer it back. So let's load Y with 0. There we are. So we should put, let's put 240 in there. So we'll publish the keyboard. Yep, it's got 240 in, and we will store that in A. So load A with 240. So there's load A immediate with 240. Let's now transfer A to Y. So we'll do a TAY. Transfer A to Y is publish A, load it into Y. So it's got 240 into Y. Increase Y to 241. We can check that by publishing Y. Yep, 241. And then transfer Y back to A. Publish Y, load it into A. And then publish A just to check what's in there, 241. So we can perform a very simple 6502 program that only contains a few instructions just by pressing buttons. And this is the key thing about making a CPU. What you need is a way to automate this pressing of buttons. So we know that load A with an immediate value is, what is it? So let's try it out again. We want to get the value of 140. So it's hold down 1 and press 7. So load A with 100 and, well, load A with whatever value you want is hold down 1 and press 7. Transfer A to Y is publish A and load it into Y. So it's hold down 2 and press 10. So transfer A to Y is hold down 2 and press 10. So you can see how each of these commands can be turned into just simple pressing of buttons, and the controller board, which is going to bring this CPU to life, does exactly that. It takes an instruction and it turns it into a sequence of button presses in order to manipulate the values that are inside the 6502.